Hello, my name is Ramey Myers. I'm the product manager for the ArcGIS Utility Network. With me today is David Crawford, senior engineer on the Utility Network team, and Larry Young, program manager for utilities for Esri. Today's session is network management with ArcGIS. What's new in the utility network? And for this session, I'd like to step back to the ArcGIS Enterprise 10.8.1 release last summer, in the summer of 2020, and start with one of our most exciting elements that have been released in some time, and that's non-spatial objects. So these non-spatial objects are applied to junction objects, which represent points, or edge objects, which represent line features. They have full connective structural or containment associations. Just like spatial features in the utility network, they participate in subnetworks and traces. They can be configured with asset group and asset type descriptors, in addition to other fields that can be used to represent object attributes. So these non-spatial objects can represent any element of the structure or the operational domain of your network. It can have network attributes or categories. You can use them to represent starting points or barriers and traces, or even network controllers. And they were designed to give you high resolution capability for your communication models or your network undergrounds to support those advanced network workflows, and to provide representation for features that share common geometries, really like those fiber strands inside a cable. Non-spatial features can be added to your network via attribute rules or manual creation from related features, or even using editing templates. So they're really powerful. And in terms of capability, they have all the capability of spatial features. So for example, let's take a look at a duct and duct bank scenario. Now typically these are structural features, and traditionally we've drawn them spatially. So a duct bank could contain ducts inside the duct bank using the containment association in the utility network. With the release of non-spatial objects, we can represent those individual ducts as non-spatial objects that represent the duct bank 1, duct bank 2, or duct 3. So that's on the structural side. On the operational side, our non-spatial elements could represent phases in a conductor. So conductor has traditionally been spatial. We could have a single linear representation, a linear spatial representation of conductor that represents all three phases. With the utility network and its connectivity associations, we could draw the individual phasing as spatial lines and contain them inside that conductor cable. With non-spatial objects, we can represent those phases as non-spatial records that could equally be obtained or could be contained inside that conductor cable. And you're not just limited to using spatial features first and then non-spatial. Any combination can be used based upon your network configuration. So we could, in theory, contain spatial features inside of non-spatial objects. We could connect spatial features to non-spatial objects, or we could structurally associate them. I think it's important for us to take a look at a demonstration here of non-spatial objects. So let's start by examining the standalone tables. We've got non-spatial edge and junction objects for the telco domain, for the structural domain. And in these tables, I have the ability to configure these objects, either the edge objects or the junction objects, using asset group and asset type configurations, just like we do for any spatial data set. The non-spatial features do have all the properties. They do have the ability to structurally associate, connectively associate, or associate by container. So go ahead and pull up a non-spatial object, a junction object that I call a node. And this node is connected to two spatial features, which I'll go ahead and flash. So we just saw the left, now I'm locating the right node. And this node also has a capability of containing or acting as a structural feature if I select the rules for it. Additionally, I can take that node and load it into my modify associations table and see these associations in the modify associations table. So I could see that this non-spatial object is connected to two spatial port devices. One of the things that I think is really interesting about the modify associations table is now I've got the ability to get insight even into the associated features, even into the features that I have a relationship with. So I can go in, I can explore the relationship, and I can also, if I'm associating with a non-spatial edge, I can place this junction object a percent along that edge midspan. All really interesting capabilities. Now let's go back to our network again. And I'm going to add in a fiber cable. And inside that cable, I have strands of fiber that are represented as non-spatial edge objects. Those edge objects give me the ability to represent my features at a higher resolution, a higher level of detail ability. Moving on, with the ArcGIS Enterprise release in 10.8.1, we also enhanced the split with relationship classes so that we could provide additional functionality on split events for features with related records in a utility network. And unfortunately, we were hoping to soon release merge capabilities, but it looks like that capability has been pushed back a little bit further to mid or long term. But we're really excited to expand the capabilities of split with relationship classes. Updated propagated values in name versions. So this is a request that our customers have been asking for some time. prior to the release of ArcGIS Enterprise 10.8, you were fairly limited to propagate network attributes in a name version in a subnetwork. You typically had to post to default and then update the subnetwork in default. With the summer's release, we've expanded the capability within the Set Subnetwork Definition panel to enable the option for our subnetwork update policy to propagate those configured attributes in a name version. And the default version of just propagating the subnetwork name is still available, and it does perform better than loading all of the network attributes in the name version. We've just expanded that capability and made it available. Now, this is looking ahead to the upcoming release in second quarter of 2021, and that's ArcGIS Enterprise 10.9. So one of the new capabilities in subnetwork management is we've expanded the subnetwork naming convention. So we've added a couple of new fields. So we've provided supported subnetwork name and supporting subnetwork name as additional subnetwork features. And you have the ability to leverage this or to not utilize it during the update subnetwork process. So let's take a look at this graphic and see how it works. So we have subnetwork 1, subnetwork 2, and subnetwork 3. And inside subnetwork 2 is a container. And that container has devices from subnetwork 1 and subnetwork 3 along with subnetwork 2 contained in it. So if we were to run the update subnetwork on these three subnetworks, what we would see in that device attribute is for device A, the subnetwork name would be subnetwork 1. The supported subnetwork name would be unknown because it's not containing a feature from another subnetwork, but it is contained inside a feature from a subnetwork. So the supporting subnetwork name would be subnet 2. Now for our second subnetwork, device B, the subnetwork name would be subnet 2. The supported subnetwork name would be unknown because it's not containing any features. And the supporting subnetwork name would be subnet 2 because the container that's supporting it is in subnetwork 2. And device C, third subnetwork, supporting subnetwork name is unknown. Supported subnetwork name is unknown. Supporting subnetwork name is subnet 2 because that container is in subnet 2. Now looking at the container that we've labeled Z, it is in the subnetwork name subnetwork 2. It is supporting subnetwork elements from subnet 1 and subnet 3. And its supporting subnetwork name is unknown because it's not being contained by another feature. So that's part of the subnetwork management update. Now, we've also provided additional capabilities on the subnetwork is dirty attribute. So is dirty is an attribute of the subnetwork that lets you know whether or not it is up to date with the network topology. So let's look at another graphic working from left to right. So our network starts with the network up to date and the subnetwork is up to date. And we have an edit that occurs in red in the second graphic. So now our network is dirty and the subnetwork is still up to date because validation hasn't been run and the subnetwork still represents all of the elements that are validated and in the network topology. Now we update in the third screen, validation occurs, and we update the subnetwork to bring those edited features into our subnetwork, and that creates the subnetwork to be dirty. So now we've got to run an update on that subnetwork. Once we update the subnetwork, the network becomes up to date, and the subnetwork becomes up to date. Or we could bypass that is dirty update. We could bypass it so the subnetwork gets updated, but the representation, the status of the subnetwork remains in a dirty status. Well, why might you want to do that? Well, let's say that you have additional edits, you have additional configurations that you're going to add to the subnetwork, but you don't want to take the expense of propagating that value. Well, you could bypass it during the update subnetwork process. Another function in the release of ArcGIS Enterprise 10.9 is subnetwork and trace validate locatability. That's quite a mouthful. So what we mean by trace validate locatability, there's a possibility now that we've got non-spatial objects. Once they're in a subnetwork, they are loaded into a subnetwork because they have a relationship with a spatial feature that is in that subnetwork. But there's always a possibility that those non-spatial objects could lose that association. You could drop them from that structure, that connectivity, that structural association, that containment, and lose that non-spatial object inside the subnetwork. Well, this validate locatability returns, in the process of a trace, it returns your orphaned objects within a subnetwork, so you can go back and clean up those elements. So in previous versions of the utility network, the utility network version was driven by the configuration of ArcGIS Pro and the UN tools that were configured within that version of Pro. Now utility network versions are driven by the server configuration in ArcGIS Pro 2.7. So for example, if an ArcGIS Pro 2.7 were to build or stage a UN in an ArcGIS Enterprise 10.7, the result would be a UN version 3. If Pro 2.7 were to build a UN or stage a UN off of an ArcGIS Enterprise 10.8.1, then that subsequent UN version would be a v4. And if Pro 2.7 were to stage a UN off of ArcGIS Enterprise 10.9, the resulting utility network version will be a version 5. Next, validate and repair utility network tool. So over the past year, we've had reports, we've triaged bugs that indicated things were occurring that resulted in inconsistency in network tables. So we built a first release of these tools, the verify and repair network topology tools, to be able to go out and diagnose some of these inconsistencies and provide an output log file of the discovered issues. Moving into the future, as part of work on improving performance and scalability of the network, the development team will continue to enhance and build up the capabilities of these two tools. Next, updates to utility network error management. So this is an area where we've gotten a lot of feedback. So prior to the summer's release of ArcGIS Enterprise 10.8.1 Utility Network version 4, error features were points, lines, and polygons that were represented along with dirty areas in the utility network layer. Now, one of the challenges is a error feature was created for every error. So if you had 30 errors on a given location, it generated 30 features. Scaling that out to large utility networks with a higher number of errors resulted in a tremendously long time in not only generating the initial network topology, but even validating network topology at that scale. So the development team has taken a new approach with this error management, and they have included the error messaging inside the dirty area feature. This enables that the associated features or objects to be represented by GUIDs, so you can look up or identify the feature from the error messaging, but its primary focus is to give you better performance and scalability when validating and returning back errors on a validation. A couple of other elements of this error management that I think is really important and I've been really excited about is displays that are represented in the Modify Associations pane. So associated features or objects that are in error are displayed with orange indicators in the Modify Associations pane along with tooltips for additional information. So that means if I've got an existing association I've got a feature that is in containment, and the element that is containing the feature is in error, it'll represent an orange tag and provide the error message in the Modify Associations panel. The other component that I think is really interesting and quite exciting is the dirty areas. So in Utility Network version 4, dirty associations are denoted by a purple indicator on the Modify Associations pane. So when you pull up an association, you create a new association with a feature, and you apply it. That green new indicator of your association is going to turn purple. And that's designating the fact that that association is dirty. Now, you run validation and you add that association to a network topology. Now, that purple indicator in the Modify Associations panel clears out. It becomes a clear spot. So, really powerful tools to help you in your error management in the utility network and with associations. Looking at changes between Utility Network version 4 and Utility Network version 5. I just mentioned the error tables that are available up to Utility Networks with version 3 have been replaced with more advanced dirty area management and messaging in version 4. Version 4 also introduces not only the non-spatial objects to operational and structural domains, but it also brings along new connectivity associations to support those non-spatial objects. So, for example, in addition to the connectivity, the traditional edge junction, junction junction, edge junction edge, we also have junction edge connectivity to include midspans. We have additional connectivity to support the objects and enable the objects to not only be contained, but to contain other features and to have those structural attachments. And then version 5 of the utility network introduces stored trace configurations, and we'll talk about that in just a moment. So I'd like to take a few moments to talk about trace framework updates. Because of non-spatial features, it really has played a significant impact in the trace framework. So the trace location pane has been updated to support non-spatial objects. So junction objects and edge objects can now be used as starting points or barriers. So how do you include an object that's non-spatial? Well, you have the ability to select it in the attribute table, and the trace pane, the trace location window, gives you the capability to add that selected feature. So now it's just not selecting features on a map, it's also add features. So that add feature function also works for spatial features as well. So now for starting points and barriers, you could select any feature from an attribute table and add it to the selected. The other opportunity is if your non-spatial object does have some sort of association with a spatial object, you can use the attribute pane as well as the attribute table to look that up and add them to the trace location pane. Next, new results type parameter has enabled output trace results to aggregated geometries. So what that means is now I can not only trace and return selected features, I can return features from a trace. I can narrow down the output using the trace parameters, and I can return feature classes that represent the output of the trace. And the feature classes are returned as points, lines, and polygons to capture all the elements of your trace components. Another new feature of the trace framework is include up to first spatial container. And that gives you a little bit more control when you're running traces in nested containment configurations. So let's say that you want to run a trace up to a station, but you don't want to run the trace beyond the station into a vault in the station. So it will go through the station and then stop at that vault container. And then filter barriers can now behave, or sorry, feature barriers can now behave like filter barriers to improve traversal behavior with network controllers. So the use case for this is, let's say that you're running an isolation trace, and your first trace is to locate the subnetwork controller. Well, you want to pass through that disconnected feature to identify the controller, and then on the second trace, as you find your operational devices, that's when the trace will stop at that barrier loop. So we spent a bit of time on the opportunities and advancement of the trace configurations. And I mentioned that one of the things I'm most excited about is that ability to output very distinct asset types, very distinct features from the results of a trace. Additionally, in addition to the conditions, I can also return the results of this trace as an aggregated geometry. That means that I can take the trace selection and propagate it out to a new shape feature, lines, points, and polygons. So the results of my trace gives me a new feature layer that I can use, as I mentioned, for inspections or other types of analysis. The trace configuration tool was designed to provide that enhanced experience for JavaScript and runtime. And it really is that first step toward a full disconnected environment. So the trace configuration tool enables you to configure the parameters of a trace, to set all the instrumentation, and store that trace inside your network service. That stored network trace now can be run in a JavaScript app or in a runtime platform, or it can be run by a user where you want to better define the trace properties. All the user has to do is put in the starting point parameter, and it'll run the exact parameters of that trace. It is configured as a JSON script, and you can export it out so you can see and interpret the results and patterns of that trace configuration. But this truly is the first step toward that full disconnected editing platform. So the last item that I'd like to cover is the ability to store or add a trace configuration. So this gives me the ability to go in and set parameters for a trace and have those parameters of the trace stored in a JSON format inside the REST services. So I'll go ahead and take a look at the properties of this utility network, and as I dive into the network properties, we see that we could see that the trace configuration that I built for a transmission connected trace is stored inside the service of that utility network. Now, what does it look like? It's in JSON format, so I can export it and I can actually see all the individual parameters and configurations that I set. Runtime API. We're really getting excited about that offline network configuration. So the runtime team is building up the API infrastructure to be able to utilize trace configurations. So I guess I need to be clear, up to the stored trace configuration tool, we've been talking about functionality in either ArcGIS Enterprise 10.8.1 or ArcGIS Enterprise 10.9. So at this point now, we're going to start looking into mid to long-term release functionality. So this runtime API is more on the midterm release, and I would certainly encourage you to attend the runtime session where they'll go over the API functionality in more detail. But the objectives of the runtime API team is to provide tools to utilize those stored trace configurations we just talked about, to be able to leverage offline utility networks, to provide enhanced tracing in field maps, and to give users the ability to have display filters in that runtime environment. Next, the JavaScript API team are working toward better enabling those web configurations in a JavaScript environment. And first and foremost, the team's working to provide tools to support tracing through the trace configurations. But there are other opportunities for tracing network capabilities such as associations and more fully functional analytics and subnetwork management in that JavaScript environment. Partial posting and version cloning. So the team is working, and once again, this is mid to long-term release. Team is looking at providing a better user interface to post selected features from a version, or to clone name versions for network design projects. Flow direction display. Team's working or the team is going to be looking at providing graphic displays based upon controller location on a subnetwork. Multiple propagators provide the ability to support multiple propagators on a single tier, propagating voltage in phase on a single subnetwork. So that's the roadmap. That's the utility network roadmap. We've got a lot of exciting things that are coming ahead. We would certainly appreciate any feedback you have for the session, and we look forward to answering your questions. Thank you very much. Have a good day. Thank you so much, everyone, for joining us today. We've got some great questions, and we look forward to throwing some answers back at you. So let's start with the first one. And Dave, I'm going to pitch this to you. What's the difference between non-spatial object and a table? Tables are how we represent non-spatial objects in the geometric network. So for example, like transformer unit table records related to a bank feature class. But how are these non-spatial objects now different than the original configuration?
Thanks, Remy. So from a data storage perspective, it's actually the same. Non-spatial records are records in a table. The real difference is how that integrates with the network itself. So as we used to store unit records in the geometric network in these related tables, via tracing or analytics or anything to do with the actual geometric network itself, it had no knowledge or intelligence of those related records, besides being able to trace to some feature and then give back information about the related records. The difference is in non-spatial objects, we actually create network elements representing each of those non-spatial things, and we stitch it directly into the network topology itself, allowing you to use analytics or any of your graph processing, as well as network diagrams on those non-spatial objects themselves. So it's a little more enhanced. It's just bringing that non-spatial bits that you always stored actually down into the network topology itself for use in analytics, diagramming, and anything else within the network.
Cool, thanks, man. So Larry, I've got a couple for you.
Okay.
The first one is any specific utility network functionality and ArcGIS field maps that are coming along that will allow field users to validate new features in the field or something like that.
Well, that's a good question. We've actually been working closely with both the Runtime SDK team as well as the apps team, and functionality starts first in runtime. So we're slowly exposing the capabilities of the utility network. The big piece we are working on now is what we call disconnected network. So the ability to take the network offline. Once we have those capabilities in the Runtime SDK, they'll be adopted by field maps, and that will allow the user to do all of the things that they want to do when they're disconnected or in the field, as far as tracing, picking up a feature, having everything rubber band when they move it, all those things they expect from a network. So we do plan to support all of that with field maps going forward.
Nice, nice. So let me throw one more question at you,
Okay.
Larry. So will the trace and leak isolation functionality, will that stuff be available in the ArcGIS online configurations that are available or being deployed in the very near future?
Okay, I think that's actually a couple of questions in one. So right now, if I understand this question correctly, through our solution site, there is the ability to deploy a network completely through online. But that network is a network of simple features. So there is no support for things like tracing. Going forward, we do expect to fully support the utility network in online as well as offline, as I spoke about a minute ago. So once the utility network is supported through online, as in via hosted services, then you will have the capability to do all of the tracing things that users want to do. Unfortunately, that's probably still several years off, because our biggest priority right now is the offline and support in the mobile environment.
So Dave, let me pitch this one your way. And the question is, can you speak a little bit about how connectivity relationships are stored at the most basic or the lowest level of the network?
Sure. So connectivity associations or relationships in the utility network are the same or stored the same as all of our associations within the network. The ability to say how things are connected or related to each other. The idea of two features being connected or attached to each other or contained within each other. They're just stored as entries or rows in a table, an internal system table to the utility network. Those entries or those records are then given some network information and stored down in the topology. And so in order to do traversals across that connectivity or those associations in any form, we can actually use the speed of our network index to allow us to pull those things out at a very basic level and return them back to the user. So we don't have to jump back and forth to feature space to do that analytic. But at its most basic level, it's just a row in a table.
Awesome, thank you. So this was another good question. Somebody asked, with these new non-spatial objects, what's the use of assembly features? And I think the important thing to remember is that you as a user or customer, you've got the ability to build your network based upon the requirements of your business. So whether you model assembly features spatially or you use non-spatial features, that's up to you. Certainly, we can, conceive that there's a little bit of interchangeability here, but certainly we anticipate that customers will still want to use assemblies to show those very, very large scale features, such as those in a switchgear or maybe a transformer assembly, that you'll still want that spatial visualization component. Really, really good question. Let me go to the next one. And the question is, and Larry, I'll go ahead and throw this at you. When will non-spatial subnetworks be able to build a subnetwork line, if only contained within a structure line?
Right, that's a good question. We actually identified that as a problem pretty early on. So the example is, you trace a telco network, for instance, that we expect to be very highly non-spatial. You don't want to model individual strands as features because that just gives you too many features. So if you're going to do a trace through a strand, how do you represent that or show that on the map? And the same thing applies then to pushing that out into the subnetwork definition. The same with underground electric. So we do plan on supporting that in the next release. So that would be, it's unfortunately not going to be in this 10.9 release that's coming out in May, but in Q4 of 2021. What year are we in? Yes, 2021. Q4 is when we will support that non-spatial as part of subnet lines.
Awesome, thank you. Dave, let me pitch this one at you. I thought it was really interesting. I talked a little bit about the trace configuration capabilities that are available now and how you can store them in the service. Can you talk a little bit about, what are some options from a parameter configuration? What can you do with this in terms of using it as you would roll it out to other solutions?
So I actually think I misinterpreted this question when I first read it. From the named trace configurations that we've just provided or just shipped with ArcGIS Server 10.9, or that's going to be coming with ArcGIS 10.9, the only thing you can really parameterize in that is the trace name itself. The trace configuration is a single entity that defines the trace. So when you go and grab it by name off the service and you say, do a trace with this named configuration, it is that trace. There is no way to configure it beyond that. From the actual raw trace itself, every input into that trace configuration, not the named configuration, but just the regular trace, can be parameterized and is exposed via the SDK, Python, or using Model Builder, which you could then script up or provide to somebody as a configuration or a parameterized experience, where a user, maybe they click and they get 2 parameters to pick from instead of the big list of however many are in that GP tool to operate the trace they're looking for.
Can I add on a little bit to that? And some of the things we certainly discussed this notion, should we allow parameterization of these trace configurations? For instance, I want to create something that's a phase trace, and right now you'd have to create an A phase, a B phase, a C phase, specific trace configuration. And the original goal with trace configurations was to allow us to easily push traces out into the field. As we talked about earlier, the capabilities will be coming with runtime and with field maps in order to use the UN to do things like tracing. And if you've used tracing in Pro, it's a rather large dialog with lots of options. And we would never expect somebody in the field on an iPhone or something like that to try to set all these parameters. So trace configurations made a lot of sense. Create a configuration, send it out with the map, because the person in the field is going to be doing something very specific, like an upstream protective device trace or an isolation trace in gas and water. So that's why we ended up going down this route of making it very specific, thinking again that this person out in the field that's going to be taking these configurations out with their map is going to be doing a specific job, and the more streamlined you can make it, the better, or at least that's our thinking. But if you have further feedback on that, please let us know. And when you do provide feedback on something like that, it's really important to tell us exactly what your workflow is, so we understand why you're asking for something like being able to change a parameter or change a setting on that trace configuration.
Right. Yeah, Larry, I think that'd be really powerful. Coming from my background, it seemed like we always had these ad hoc type queries or traces that we would have to stand up like in emergency events that were not necessarily part of the planned business, and having the ability to be able to configure these out and roll them out as a service. I saw that as something that I was really excited as a former customer. And I think those capabilities will be really powerful.
Right.
So I've got one more question that I thought was really interesting, and it's really something that we try to communicate. And the question was, how or when will hydrologic analysis programs such as WaterGems or Innovyze be able to use or to be able to integrate with the core utility network data for analysis? And I think the important thing to remember is that's a real core driver of why we built the utility network. That services architecture is designed to be integrated with third-party solutions. So you can use the utility network for your primary source of location and have it integrated with analytic solutions such as Innovyze or WaterGems, or even ADMS, EMS, or customer service solutions. But having that services-based architecture enables an added level of security in terms of communicating with those systems, but also enables you to really dial in that performance and analytic based upon the customer's need, and not have a one-size-fits-all. I think that's really something that it's important to remember when you're building out these solutions or building out these functions. So since we've got a little bit more time, Larry or Dave, is there anything else that you saw in the questions that you'd like to respond to or like to comment on?
I just, if it's all right, Remy, I just brought over
Yeah.
a couple more questions that I'd like to take a shot at. The first one was, have you seen anyone create a domain for modeling the flow of air through sewers? And I brought that over just to make the point. Unfortunately, no, I've not seen anyone actually do that. But I just want to reinforce the point that Esri puts out a certain set of models, ones that we see the most use in, and we put out these models at starting points, and there really are meant to be starting points, meaning that users are free to add additional tiers within their subnetwork. They are free to remove tiers if they are not using them, which we've seen quite a bit in the gas model already. They're free to add fields of their own to make that model their own. They also have the ability to create their own domain models, and we really hope that partners will pick up in this area as well. So for something like airflow, where at this point at least, I don't see us creating our own model, hopefully a partner can pick that up, or an end user still has the ability to create their own if they want to. And then the second one I brought over was with the related tables and asset hierarchy. And with that question, I wanted just to reinforce the fact that history is maintained within the utility network. It's built into branch versioning. So when you bring any table, for instance, if you have related tables, if you want to bring those in as non-spatial for the reasons Dave talked about before, to make them part of the network, anything that is within branch versioning, even if it is just a related table, all the edits are stored as part of the history. So you have the ability to roll the network back automatically and look at what the network looked like last year or the year before, or whatever your requirements are in that area.
Well, and I have two questions in here, one of which is getting a lot of likes from people, so I'll try to answer, and then another one that is not, but it's interesting to me. And so the first one is, what happens to the UN version when ArcGIS Enterprise is upgraded? Example, going from 10.8.1 to 10.9. Would the user also have to update the UN to version 5. So the answer is, when you upgrade your ArcGIS Enterprise, nothing happens to your utility network. We do not silently upgrade it behind the scenes. We don't break it in any way. We don't make it all of a sudden unconnectable. All of our old models, version 3, version 4 of the utility network, continue to be supported on the newer releases. You could remain on a v4 network using 10.9.1 or 10.9 without any problems whatsoever. The problem or the issue is that if you want to take advantage of any of the new functionality, example, named trace configurations, they are only supported using a version 5 utility network. So once you've upgraded your enterprise to 10.9, you can continue to work with your data as is. But now if you want to start taking advantage or leveraging some of those additional capabilities that we've released, you then need to upgrade that utility network. It changes some of the schema, adds a system table to support name trace configurations, and then enables that behavior through the platform. So that's sort of the high and the low of it. From a blanket statement, we don't touch your network. We stop the service, you upgrade your enterprise, we restart the service, and you're back up and running. But it gives the option for you to upgrade it later.
That's a good point, Dave, because I actually got that question internally last week from our support team, that a user was asking them or telling support that they couldn't upgrade because they didn't want to upgrade their UN. So we had to make it clear, and we're actually in the process of updating our help to make it more clear that you can move forward in the version of enterprise and not worry that your network is going to be upgraded to a later release. So good question to bring over.
And the other question I saw was the question, can subnetworks be subdivided? And if so, how far? So our domain networks within the utility network have two different configurations, partitioned or hierarchical. Partition networks cannot be subdivided. Once you open and close switches and you create different things, each subnetwork, each feature really belongs to a single subnetwork, with the exception of some cross-fed features or features that are in a shared location. But generally speaking, one feature belongs to one subnetwork. Whereas a network such as a hierarchical network, like a gas network, what you might end up having is you could have one large subnetwork, and then within that have smaller tiers of subnetworks. For example, a system tier subnetwork is a big thing, and then within that you have some distribution zones, and then within those you have some isolation zones. Each one of those tiers or hierarchies gets their own set of subnetwork controllers that define what each of those individual subnetworks look like. But in that case, one feature can participate in each level of the hierarchy. So at the bottom end of the hierarchy, they're in this network, and the next level of the hierarchy, they're in this network, the next one, they're in this one network. If so, how far? I don't know that there's a limit, but there's probably a practical limit. You likely don't want to maintain these hierarchies unless they are of actual value to you. You can imagine if you created a system hierarchy, a system tier that is the entire network, a couple million features, for example. Every time you try to update any of those features, you're updating all of those, the tiers in the hierarchy, all of those subnetworks. So you can imagine it could start to introduce some interesting performance issues for yourself. And so you just want to be very careful about when you define these hierarchies, what is the value of them? What do they bring to the table? You don't want to define a hierarchy just because it seems like an interesting stretch of the system. It should have some actual business case for you, some actual use case.
So I've got a couple of additional questions as well. The first one is, are there any plans to release an electric foundation model with non-spatial objects? So talking to the Esri Solutions team, we do know that they are working on a model that has non-spatial objects, and the last I heard, they're anticipating releasing it sometime around the enterprise release in May. So that's coming pretty soon. Definitely keep your eyes out for it. And then the last question I'll touch on, how the UN support, or how does UN support an export to the SIM model? That's a really challenging question, because in my experience, coming from a utility, SIM changes drastically based upon the function of the work, the operation work, and the business practices. So in theory, one, if you want to build a utility network that supports a SIM extractor, you have to configure your utility network with the features that will be included in the SIM. Now, we do have a number of partners who've got really capable, really powerful SIM extractors. Those are options. But even before you get to the extractor capability from export subnetwork or even pulling it from the services, it's really important that you have to model your network to be configured to handle all of those elements that you want exposed in the SIM. So that's just something to really keep in mind as you go forward and you're looking at rolling out a SIM flavor of a utility network.
Is that our time? Are we out of time now?
Okay. So I guess that wraps things up. Thank you so much for joining us, and we look forward to your questions. Please reach out to Larry or I if there's any other questions that you have. Thank you and have a good day.
Thank you, everyone.